Today's meeting is, we listened a lot about how analytical chemistry can, be a significant asset for what we do with the bees. So in these presentations, we have two pillars. The one is the phytochemical analysis conducted in Benaki, and the other has to do with the macro and trace elements conducted in the University of Tuscia in Italy. So I will stick to the phytochemical analysis part of honey, and then Pier Paolo will come back. Just few words, though, just to recap that the Plan B is a coalition, as we say, of several partners, and it's a teamwork. Since it is a multifaceted project, it needs a good alignment between the partners in order to furnish the best results. So we can go to the next slide, Sabri. And just to remind to those that do not know probably that our project was financed by and is financed by Prima Foundation and took an extension of 1 year due to the COVID. We are primarily, let's say, a field-based project. So some of the experiments, some of the trials could not be performed. So Prima Foundation, with their understanding, granted us an extension in order to, to deliver everything on time and to achieve, let's say, the maximum outcome. We can go to the next slide. A few words about the objectives of the project, and is, as we already see in this today's session, about how to provide new tools, IPM tools against the crop and the honeybees. To valorize, a lot of presentations have been done on the how we will valorize these well-adapted endemic honeybee subspecies. To improve, of course, to do this, we needed to propose a farming system that will combine citrus and honeybees. To improve the quality and the safety and the stability of the honey produce, to ascertain the environmental and socioeconomic sustainability, and a follow-up presentation will be on the socioeconomic analysis, and of course to promote any new products that will be produced within the project, that it can be a honey, it can be a prototype or a patent or whatever is related to the scope of the project. But without the case studies, we couldn't have honey. So we need to, just to refresh that, in Plan B, we had case studies in 4 countries, but honey was produced only in three countries. Spain is an individuality on this pillar, since there is a, there is a contradiction, a conflict between the honeybees placement near citrus orchards. In Egypt and Greece and Italy, it was feasible to perform these case studies in which honeybee hives were placed inside the citrus orchards. So we can move to the next slide. The chemical analysis within Plan B has to do with some, let's say, basic criteria of the honey quality that is also addressed in the European Union legislation, such as the content of sugars, the moisture, the humidity, other parameters such as enzymes, such as the diastase enzyme. But a lot of effort has been given to the appropriate phytochemical analysis that is important also from the traceability and the quality of the product. Today, we will not speak about the contaminants, but in Plant B also, honey and citrus is also analyzed for pesticide and metabolite residues in order, as you have already seen in a video, to address any potential contaminants that arise. These honey bioactive phytochemicals are divided in 3 categories. Of course, there are other bioactive chemicals that can be addressed using the state-of-the-art equipment that is used within Plant B. These can be the phenolic acids. Some of these compounds are also mentioned and analyzed in other activities within Plant B. The flavonoids and the volatile compounds also mentioned within today's session. And the important thing is that we follow a rationale of liquid chromatography that is in conjunction with mass spectrometry, either in a simple mode or in the untargeted high-resolution mass spectrometer, in order to unveil unknown compounds that are not in the scope of the analytical methods. And by this way, secondary metabolites are identified, which is very important also in the efforts to, which is a bit difficult, let's say, to try to discriminate citrus honey, not different type of honeys, but citrus honeys from 3 different countries. I need to mention that within these 3 years, we've managed to collect approximately 100 honey samples, and a lot of information was the outcome of huge analytical work. And of course, gas chromatography, it was also mentioned within the session, is also very important, because even though a lot of types of honey are vastly addressed with gas chromatography, still there are margins to unveil new compounds that have not been mentioned in the specific type of honeys. So the first approach with the phytochemicals is to try to have a targeted method with which we could have performed quantitative analysis. So we build upon an existing method in our lab, and we extended the scope to more than 65 bioactive compounds. And the chemical analysis was very important, because we've managed to analyze the first 2 years samples, and now the 20 and 22 honey samples are currently being analyzed. And it was very important because this type of chemical analysis was complementary to the untargeted analysis that we will see to the next slides. And actually, it was very important in order to cross-check our results and verify the findings. So apart from the targeted liquid chromatography that was in conjunction with photodiode array and mass spectrometry, we also used gas chromatography mass spectrometry to analyze honey samples. For those that are involved in chemical analysis, it was also mentioned before, the solid phase microextraction is a very good approach in the effort to capture volatile organic chemicals, volatile or semi-volatile compounds that in the end can be analyzed. Of course, for honey, we used the headspace mode, which means that all these fibers were exposed to the headspace and not inside any solution. By this way, known compounds found in citrus honey, such as the ones that are already seen in the specific chromatogram, were identified, such as lilac-aldehydes and methylanthralenate. But in this slide that Sabri right now turned, is important to see how different chemical profiles can be derived from different types of honeys, because in Egypt, we had some types of honey that were not citrus oriented. So it is indicative that between citrus and basil, honey a different chromatogram was furnished, which means that also there were differentiation in both in the number and in some of the chemicals that were expressed in honey. For just to stress a bit on some compounds reported for the first time in citrus honey, we did identify in Greek citrus honey 2 furanone derivatives that, to our knowledge, are not reported, and these are shown on the left, the chemical structures. So this part of the chemical analysis is finalized, and the totality of results is currently being assessed. We can go to the next slide, Sabri. But as we said, it is important in the context of trying to differentiate honey between considering both the botanical and the geographical origin, it was pivotal to implement the untargeted chemical analysis. This was conducted, there was an experience in the lab, but we optimized the sample preparation step in order to deliver as much as possible, possibly clean extracts, but with full of information. And this picture that is presented right now shows the chromatograms from the LCH RMS system, both in the positive and the negative mode. So these are overlays of chromatograms of the three countries, and this part of work has been finalized for the 2020 samples, and now from the beginning of 23, the totality of samples will be also subjected to this type of chemical analysis. What I've mentioned before is that the high-resolution mass spectrometry not only identified new molecules, but also verified findings of the targeted chemical analysis. And of course, all these data are currently being processed and will be also processed in their totality in the beginning of 2023. We can go to the next slide, Sabri. So the metabolomics approach that we used within the plant B, it was pivotal because we've managed to differentiate actually the honeys of the three countries, and approximately 40 secondary metabolites were tentatively identified and can play the role of chemical markers of citrus honey. So from each country and from each citrus type of honey, we have identified some chemicals that are differentially increased in each country, so they can play a role in the attribution of the geographical origin and also the botanical origin, because it was mentioned, it was shown in the videos, in some of the citrus orchards, aromatic and medicinal plants were installed. So maybe citrus was the dominating crop, but also aromatic medicinal plants were there, and to an extent they can contribute to the composition of the honey. I need to mention here that also colleagues from a General Chemical State Laboratory in Greece, who are experts in the melissopalynological analysis also, they also conducted same analysis that all these results are already drafted, and we have 2 manuscripts now in preparation. The one will be submitted coming 2 months for consideration to be published. So this chemometrics approach, considering all these data that were produced within the high-resolution mass spectrometry, the untargeted analysis, adds to difference citrus honey from the 3 countries, which we consider it's a good step and is in line with what we have promised to do within Plant B. And of course, this is a teamwork. We, the people in the lab, we could not do anything if the people in the field do not work. So, you know, this is completely related, and their information and our information is important on a bilateral basis. So I would like, Sabri, I have finalized for Pier Paolo. I would like to thank you for your attention, and in the later QA session, we can address any questions. Okay.